Hey, thank you very much, Victor. And hi, everyone. My name is Terumi Laskowski. I'm actually working from home in Hawaii. I've been like this for a while now. And I'm a CCSK instructor. So I've been working with CSA for about 5 years now. And also, I'm also a AWS instructor. So today, I'm going to be picking a topic within a security guidance for CCSK and showing you, a couple of best practices of how to implement that in AWS. I hope that's going to be of interest. So let me go ahead and share my screen that I have. So hang on. By the way, I have three dogs. I call them my boys for my moral support. So sometimes they kind of give me a yell to say, "Hey, mom, get energized." So if you do hear that, please just go ahead and ignore that. Okay. Anyway, so I hope you see the screen right now, the security guidance. Can somebody give me a positive on that?
We see it.
Okay, great. Okay, so I hope you were able to look through the guidance because it has great nuggets of knowledge about cloud security, and also it's a great resource for vendor neutral cloud, right? But so let's take a look at one of the items that's here. Today we're going to be talking about network intrusion detection, okay, network intrusion detection. And let's see what security guidance has to say about network intrusion detection in a cloud, right? So if I do, I think I did sniffing, yeah. So if I were to go ahead and search on sniffing, and let me make that a little bit bigger for you. Let me make that a little larger as well. Okay, so this is where we're talking about how security changes with cloud networking. And we'll talk a little bit later on about what SDN, the software-defined network, and how AWS actually implements that. Now, I don't know to a degree because I only know what AWS puts out, but I will share with you, what they say, how they do it. But in this guidance, one of the things that's interesting, right? So let's see here, right? So if you look at this, the lack of direct management of underlying physical network changes common network practice for cloud users and providers. Okay, so cloud, right? Everything is abstracted away. Not everything, but a lot of things are abstracted away. As a minimum, the infrastructure, the actual network, the physical network, the actual network servers and such are abstracted away from us. So as security practitioners, how do we bridge the gap if we want to monitor what we used to monitor at the physical level? Okay, so one of the things that they talk here is, let me see here. So if you look at this part right here, it says traditional network intrusion detection systems, right, where communications between hosts are mirrored and inspected by virtual or physical intrusion detection system, it will not be supported in a cloud environment, right? So that's the major problem. So you see here it says the customer security tools relying on an inline virtual appliance or software agent installed on instances. That's basically how it needs to happen. So here, this is the part, let me see here. Let me see. Yeah, so the major point that I actually want to talk to you about here is that you actually have to do everything inline. Now, let me do a little whiteboarding to emphasize why that is important and why that actually hampers how we normally do network intrusion detection. Okay. All right, so let me get my whiteboard out here just a bit. Okay. So normally when we do network intrusion detection, let's say you have a physical network, right? And you have, let's say, a couple of servers that you want to monitor their traffic. And let's say that you have a intrusion detection system, right? So if we were to say that's the IDS, intrusion detection system, and of course, this is a network, right? Network IDS. What's happening with the IDS usually is that if we're assuming that this is Ethernet, we're relying on the fact that everything that travels across the Ethernet goes to everyone, right? So that means if these two hosts are speaking to each other, that traffic can also be made available to the IDS. Right? So IDS should be able to pick up everything. okay, everything at all. And if we were to take a look at this and say, but Jeremy, right now we use switches and stuff, and switches, they don't broadcast all these messages all over the place. That's true, okay? Okay, so I was just kind of looking at the chat, sorry about that. And so basically what happens in this case is this. So normally, if we're looking at the physical, let's say, topology of intrusion detection, let's say one line comes in, this is the ideal, and then you would have something called the splitter, right, that splits the traffic in two. That's what we're looking for, right? And then you have all the hosts on this side so that, they can speak normally. And then you have an IDS usually here, right? And when the traffic comes in, everything travels across here as well, but also the same traffic will go to IDS. So in this setup, you have IDS, once again, picking up everything, right? But notice that how IDS is positioned, they're in parallel, right? They're not in line. So if we're talking about something that is in line, we're talking about something like a firewall, right? So if you have a firewall, normally, you would have something like a firewall here, right? And then you have on the other inline, because it is the inline inside the network, whereas this is parallel. Okay, and as you saw on the guidance, it says that, look, if you want to do IDS, you have to put it in line. Well, the upshot of that is just replace that word firewall with IDS. Okay, and now they're saying that this is basically how it has to operate, right? But this actually, yeah, it's true that you'll see everything that's going in and out of the network. But another thing is that IDS is going to be the bottleneck, possibly, right? And you don't want IDSs, intrusion detection system, they're like a security camera, and you don't really want that to be, a cause for slowing down your network, okay? That's why parallel is preferred. But then you may also say, but Jeremy, when was the last time you've ever seen a splitter? Eons ago. So how do you actually, do that in real life? Well, normally you will use a switch, right? So let's say you have a L2 switch. Let's say this is an L2 switch. And, you have a bunch of ports and stuff. I'm just going to go four ports here, okay? And then, you have these, let's say, you have these hosts. But with L2 switch, you can also divide these things up into VLANs, right? So that means if you do a VLAN, let's say VLAN 1 and VLAN 2, host number 1 and host number 2 is not going to be able to talk with each other because logically you separated out the network. So where would you put an IDS so that the IDS is able to see everything, regardless of whether there is a VLAN or no VLAN? Well, there's always one VLAN, but in that case, well, normally you would have a very, very special port. Sometimes you call it the trunk port. Okay. Or sometimes, on the high-end L2 switches or L3 switches, you would have actually an IDS port. Right? And this is where you would put in your IDS. So that, once again, you see everything. This is normally how you implement IDS as intrusion detection system, right? They have to be able to see everything. So the question is, why can't you do this in the cloud, right? Well, one reason is because you don't have access to the L2 switches, do you? Right? So the L2 switches belongs to the cloud vendor, and they're the one that manages it, so you don't have access to it. Okay. But the question then is, well, can you mimic something like that? Can you mimic like an L2 switch with the IDS port or something, so that you can actually have a device that's kind of waiting for that? Okay. And the answer here is unfortunately no, right? So specifically with AWS, let me show you what that looks like. So before going forward, we have to kind of talk a little bit about SDNs, right? So software-defined network, and how networking is presented to us when we're using a cloud vendor, right? Now, like I said, I'm going to be showing you the AWS case, but this applies to almost all the cloud vendors, right? So SDNs, right? So this is software-defined network. Sorry, that's my dog. Hang on. Hey, wake up. So how dare he sleeping on my my class software. Sorry. Defined. He must have heard my my presentation like dozens of times. I think he's just getting bored. All right, software-defined network. Okay, and actually, there's a very nice blog that shows a great picture. So I'm gonna show you his site right now. So let's see if I can find that for you. Let me see here. All right, so where did I put that? There we are. Oh yeah, I have it. So hang on. Let me give you that site. We are, oh, hang on. Today's notes. Let's see, just a moment. I think it's this one. Nope. Sorry, I had it all prepared, and of course.
Okay, that makes it fun. Live demos and live sessions. Otherwise, everything is so well scripted in a recording session.
I know, right? So let me show you. So here we go. So this is a great site, by the way. So the SDN, the main characteristic of SDN is that you actually have a physical layer at the bottom, as you see. Normally it's called the underlay, right? Completely separated out from the software logical layer, which is called the overlay, right? And because the overlay is usually the brains, right? We call them controllers usually. Okay, so you have controllers at the top, and you have the actual physical data transmission layer or data plane at the bottom. So that's that separation, right? And normally, as cloud users, we only have access to what overlay provides us with. This is where we create all our, VPCs and all that. And we don't get to touch the underlay, right? We don't get to do that at all, right? So if that's the case, how does AWS do it? Okay, so one of the points here is that we have to be able to grab hold of the traffic that's going through. So if it's L2, we want to be able to grab hold of the L2, what's called a frame. L2 frame contains all the information that's traveling across. So we want to grab hold of that, right? But we're not able to, because we don't have access to that layer. See, that's the problem, okay? But why is it that we can't get hold of it? Not only is it because we are actually, not touching the actual physical layer, there's actually another reason why. This is the way AWS actually implements their SDN, software-defined network, that makes it almost impossible for us to do so. So for example, let's say we have a virtual machine, right? So let's say we have a VM. Let's say that's a VM. Okay, and let's say this one belongs to 10.0.0.2 or something, and then you have another VM that belongs to the same network, but we say VM2, and let's say this is 10.0.0.5 or something, right? So in reality, if you're, let's say, pinging this one, that's basically what you want to ping, right? So, and you ping things, let's say, that's in your network, but this is not actually how it's actually physically organized. The way that this is organized is that you actually have a host that is actually hosting your virtual machine, right? And chances are you're not going to get your virtual machines on the same physical host. So let's say you have two different hosts. So these are the physical hosts, right? That is being that's being used. So let's say this is the host 1, and this is host 2. And then, of course, these hosts are connected to the actual physical network, right? So here's a network. And just for kicks, right? Let's say these hosts have an IP address that's 192.168.0.10 or something, and here 192.168.0.1. 0.0.21 or something, what have you, okay, /24 network, okay? So in order for this VM, right, to talk to the second VM, it's not actually talking straight, right? It actually has to go out of the host, which has an IP address of 192.168.0.10, and has to go into 0.21. And then that communication has to be translated over into the host. So the communication is going to look something like this, right? So it's going to go through this, and then it's going to travel across this network, and then it gets sent up to here. So how does that happen? Right? Because and you could have tons of other people that's using the same, let's say 10.0.0.2. You may have like hundreds of people that's using that same IP address. And the trick that the AWS uses, the magic the AWS uses, so that those IP addresses do not collide, is that they actually have a service that maps, right, these network information. So take, for example, so you have something called a mapper, I believe, mapping service. I think that's the name of it. I don't quite, yeah, I'll give Victor the link to the YouTube where they talk about that. So let's say there is a mapping feature, okay? So what happens is that, let's say you're trying to ping. Well, when you say, hey, I want to ping, right? So let's say here, I want to ping, okay? Before you can ping, for those of you that knows a bit about TCP/IP, it has to find the MAC address, right? Let's say of the VM2. Okay, take for example, right? So because if you don't have a MAC address, you're not going to be able to talk within a same network segment. So before it does ping, it's going to do an ARP, right? Which is a broadcast. Well, you can't broadcast. Right? So basically on AWS, you can't broadcast, right? Why? So where does it go? Where does the broadcast network go to, right? So what happens is that this ARP is captured, right, so to speak, by the mapper, okay? And then the mapper knows everything. It knows every single instance that you have in your account. It knows all the MAC addresses. It knows all the IP addresses because it's the one, that knows it all. Just imagine like a huge database, right? So that means the VM2 information that you're looking for, with the MAC address, this one has a MAC address, right? It's going to be returned by the mapper. It says, oh, hey, you want to do it? Oh, here it is. Here's the MAC address for VM2. And when VM1 receives it, it looks just like a regular ARP reply, but it's not. It's being created by the mapper. And notice how the mapping service does not even contact the VM2. It doesn't have to because it has that information already, okay? So if this is how AWS in general does, their networking, that means how do you sniff this traffic? You cannot, right? You cannot sniff it, right? Because unless you point to the IDS and say, I want this data specifically to be going to the IDS. That's what you have to say. You have to be explicit about the sniffing. You can't just plug in a sniffer like you probably could, let's say, on the switch. Okay. By the way, any question on that part? How you can't really, do a parallel thing because there's a mapping feature right inside it. Does that sound okay? Right. So now what I'm going to share with you today is, well, how do you do this thing? How do you actually have an IDS so that you could have a semblance of network monitoring, right? Or sniffing. Right? So let me show you the lab that I actually have prepared for you. So let me get that here. Let's see. So once again, I did have this thing. So let me see here. Hang on. I have so many ones here. So all right. So here we go. Let me copy this, copy image, and let me put it right here. Okay, so the lab that I have set up for you is this. So what I did was, for you guys, I created the lab where I have this is a VPC. I named it class VPC, okay? And I've set up something called Guacamole. I'm not sure if you know this, but this is for VNC. So that I can show you what's inside, I can show you the display. I have a Wireshark instance. So this is where I have my Wireshark installed. Okay. And I'm going to be able to SSH into it. By the way, just a little, right, just a tidbit of security here, right? You don't want to be able to SSH directly into your instances, right? Because SSH port 22 is a very popular, target, right? For people that want to connect to it and hack into your instance. So you want to be able to have some kind of an authentication scheme before that. Now, I'm not sure if Guacamole is the best one, but that's what I have right now. So I don't allow SSH directly into Wireshark. I do not, okay? So let's say this Wireshark is our IDS. Okay. Then I set up one server that I want to be able to monitor, right? So this is the Nginx, so that's just a web server, right? And here's the thing. So how do you do this monitoring? Well, AWS actually provides a feature called traffic mirroring, right? And I'll explain what traffic mirroring is, but basically everything that comes in, right, by, I'm going to, talk to whoever is talking to it, okay? But at the same time, it's going to ship all that information into my IDS. So this is called the traffic mirroring, okay? So notice how the Wireshark is not getting in a way. It's not in line per se, right? Into the Nginx, right? It is in line in a way that, the Nginx actually have to, the traffic mirroring service actually has to send that information, but it's none of your instances that are kind of like being blocked by an IDS, right? It's not sitting in front of it, okay? It's like behind the scenes. So this is great, right? This is wonderful, so that you actually have a lot of options when you're setting up the traffic mirror, which I will show you. Okay, but anyway, so this is the lab environment, and here I am, right there. Okay. By the way, if you're interested in recreating the lab, I'll give Victor all my notes and stuff so that you can recreate the lab on AWS. Okay. All right. So with that said, let me actually refer you to the documentation for AWS in doing traffic mirroring. Okay, so the traffic mirroring documentation is here. Okay, what happens? So the traffic mirroring, you have to divide this thing into source and target. Right. So the source, as you see here, is the source of the traffic. So in our case, it's going to be Nginx. The target is who's going to be receiving that traffic. So in our case, it's going to be Wireshark. Okay, and so here's what's interesting here. The traffic that is being sent uses another Sdn protocol called the VXLAN, right? So it's an extended VLAN. So here, this is it's a protocol that is used often by people who does SDN. Okay, and it's interesting that actually AWS has its own SDN structure to create all the magic that they do. But in this case, they're also using VXLAN to send that information. Now, without going too much into the detail, you'll be able to see when I show you on my Wireshark the captured traffic that I'm going to be sending to Nginx, what this VXLAN looks like. But just to kind of summarize what this thing is, it's a L3, so layer 3, right? Encapsulation of L2 traffic. Right, so you're going to get a layer 2, which is data link layer traffic, riding on top of L3. Okay, and once again, I'm going to refer you back to the excellent article that I just showed you. So hang on here, let me see. All right, so what did I do with that? All right, so I think I must have put it here someplace. Anyway, that's fine. So what happens is, and I've received this question before, I said, well, what does that mean? I don't understand, right? I don't understand what, L2 and L3. Well, think about VLANs, right? So VLANs, so think about L2 VLANs, right? So L2 VLAN is where you have L2 switch, layer 2, okay? And you divide this thing up into, let's say, multiple VLANs, right? So if you were to take a peek inside here, let's say this is VLAN 1 and VLAN 2, right? If you take a peek at the actual frame that's going across, you're going to have a VLAN tag that will handle like a little bit over 4,000 VLAN, by the way, right? And so you're going to have like, V1 here or whatever, right? That's basically what it looks like. But what it's doing is, remember, this is layer 2. So you have, this is layer 2 information that encapsulate another layer 2 information, right? So it's layer, 2 networks, and let's say a router. And you want to do a VXLAN on this, right? So let's say you have a host here and host here. The information that travels across obviously is not L2 because it has to go over the router. So this is L3, with IP addresses and stuff, right? So that's L3. But what's inside it? Right? What's inside it? Well, what's inside here is an L2 information that this thing wants to talk to, and this thing wants to talk to. So that's the difference between a normal VLAN and the extended VLAN, right? So AWS actually uses extended VLAN so that they can actually navigate across multiple network segments using routers, and then still, though, maintaining the integrity of the L2 information, layer 2 information. Anyway, so let's go ahead and take a look at it. All right. So let me explain my, show you my lab. Okay. So here is AWS. And let me show you the VPC first. Okay. For those of you that's not too familiar, VPC is a virtual private cloud. So that's like a network, right? So I've created a sample network, and I named it class VPC. There you go. There's that class VPC, okay? And I have 3 instances running on the class VPC. So just disregard Open Daylight. So I have Nginx, I have Guacamole. You can ignore Guacamole, right? That's how I log into stuff. But basically, we're interested in Wireshark and Nginx, okay? Key address. And I'm going to open up the web server here. All right, so it's running, right? So I could be like, sending stuff, right? And attackers could be sending stuff, and that's what you're trying to capture. All right, so whether there is some suspicious activity going on or not. Okay, so then let me also show you my Wireshark. Okay, so my Wireshark. Hang on here. Exit. Okay, so I'm going through this using Guacamole. So just for those of you that may be interested, let me show you what a Guacamole looks like. So there you go, right? I have a Guacamole running, and I will log in. So there's no direct access, right, to these instances using SSH or VNC. By the way, Guacamole can handle RDP as well. And I'll log in. And obviously, I've already set up the Wireshark. So that here I can just go ahead and SSH into it, and you'll see, that's my SSH into my Wireshark instance. And then let me log into it using my VNC. Oh, you know what? Let me check to make sure my VNC server is working. Yep, looks like it's working. All right. Live, right? So here we go. Let's do VNC. And voila. Okay, so this is Debian, and I'm going to open up my Wireshark. Here we go. Now it's going. I'm hoping that you'll be able to see something, right? It's kind of small, but I can't make this any bigger. Sorry. So right now, it's actually recognizing the Ethernet 0. So that would be the Elastic Network Interface, or ENI, which is the equivalent for network interface card for that Wireshark instance. But right now, even if I were to start a capture, it's just going to capture everything that comes to it, right? It's not going to capture anything that's going to the Nginx, okay? Because there's no connection there. So let's create a connection. right? In fact, I've actually already created a connection, but let me go ahead and stop this, right? Just to make sure that I can actually get through this lab without stumbling across. So we're going to go back into the EC2, okay? And let me show you how to do the traffic mirroring, right? So, but just to make sure that we are, on track with what I've just shown you, is that it's the lab environment. So I've actually shown you the Wireshark. I've shown you Nginx, it's working. So now we're going to create this connection, which is a traffic mirroring between Nginx and Wireshark, right? And then see if we could actually capture the Nginx sending the VX line traffic into Wireshark, right? So here we are. And in fact, I actually do. I've actually created this the mirror, but I'm going to delete it right now. Okay, I'm going to be very bold. I'm going to delete it. Okay, so that I can recreate it in front of you. All right. So let me go ahead and delete this thing. So you can see how they're created. I'm going to delete this thing too. All right. There's only like 3 things that we need to do, right? So I'm going to delete that. All right, so now there's absolutely no connection between the Nginx and Wireshark. Now we're going to create it, right? So first thing we do is mirror the target. Okay, so we have to kind of define, okay, who's going to be receiving all this traffic mirroring? So we'll say create traffic mirror target, and I'll say Wireshark, right? And choose a target. It's going to be network interface for Wireshark, right? So there's a load balancer as well. By the way, if we do a load balancer, this is kind of neat. You could do something called endpoint connection, but we're not going to do that. So I'm just going to kind of plant that seed, right? But anyway, so it says, hey, what is the what network interface are you looking for? Well, I don't know. So let's go to Wireshark and let's look at networking. And bottom here, they give you the network interface ID, see ENI. So I'm going to copy that. That's going to be that area. So then I'll just go ahead and put it right here. So that's the one. All right. So here's the network interface. And I'll say name Wireshark. So that's good. So I've just created the target. Okay. So next, I have to tell the service, what traffic do you want to send to this target? Like, do you just want to send TCP? Do you just want to send UDP? Or do you want to send everything? Do you want to send everything that's coming in? Do you want to send everything that's going out? I'll say everything, right? Just give me everything, right? So that's called the filter. So here we go. Let's go and create the filter. So here I'll say Nginx, all traffic or something like that. Okay. And then there is the inbound stuff, outbound stuff, because Nginx will be receiving stuff, Nginx is going to be sending stuff out. I'll say I want all of it, right? So here I'll say add rule, and here I will say all protocol, and the source CIDR and destination CIDR I said anything, right? So if it's anything, it's usually called 0.0.0.0/0. So that means everything, and I'm just going to copy this thing right over here as well. And I'll do the same thing for the outgoing. I want everything. So I'll say outbound rule. Oh, I'm sorry. I just added the outbound rule. Let me add the inbound rule. Okay, so here we go. And protocol, I'll say source. There you go. So now it says, look, take everything and send it over, right, to Wireshark. Alrighty, so I'll create it. Okay, so the rule has been created. So now we have to make that connection now, right? Using the target and specify the source and apply the filter, right? So here we are. So what we're going to do is go to session, okay? And this is where I'm going to tie those things together. So create a traffic mirror session, and I'll say this is, Nginx to Wireshark. And the mirror source, once again, it's going to ask for that. So I'm going to go back and I'll go and grab the Nginx's networking interface. So I'll say, yep, that's the one. That's the interface. And hang on, just move this thing over. Right. So here I'm going to put the interface. There we go. And the mirror target. Well, I've already registered the mirror target, Wireshark. There we go. Anything else? Anything else? We have to put something called the session number. So I'll just put 10. It's a random number. And I'm going to apply the filter. So I'll say Nginx all filter. There you go. Okay. And I'll create it. Okay. Looks like everything is set to go. And of course, proof is in the pudding, right? So what I'm going to do is I'm going to go back to Wireshark and I'm going to start the capture, right? And then I'm going to go to Nginx and I'm going to create some traffic. I'm going to go back to Wireshark and see if that traffic was successfully captured. Okay. All right. So I'm going to start a capture here. I'll say continue without saving. That's fine. And I'll go to this side here and I'll say, all right, do your thing. So I'm just, going a couple times over, right? Just creating some traffic. Okay. And then I'm going to go back to Wireshark and I'm going to stop it. Okay. And so now there's tons of information here, right? And, there's a whole bunch of VNC stuff. How do you tease out stuff, right, on Wireshark? Well, as it turns out, the extended VLAN traffic comes in through a UDP port, UDP port 4789. Okay, so if I were to filter on UDP port 4789, I should be able to see stuff. Also, it's only coming in through UDP, right? User datagram protocol. So if I filter on UDP, I should also get that too. I'm just going to pick the simple one. I'll just say UDP, right? And just filter. Okay. So now what you're seeing here is you're seeing UDP traffic that's been filtered from Wireshark. Okay. And hang on here, just a moment. And so let's see. I'm just going to grab one of the one that says HTTP. I'm just going to grab that. Right. So that one. Okay. So I sorry guys, like I said, I know this is small. I hope you're able to expand it later on. Okay. But let's take a look. So you're receiving a frame, right? So frame is everything that comes through Wireshark, right? So that's layer 2. Well, actually layer 1, right? Layer 1/layer 2, because Ethernet is layer 2, layer 1, right? And then you have an Ethernet information. So here, because it's Ethernet, you're going to get the destination MAC address and source MAC address, right? Hang on. Once again, my dog has fallen back. That's why he's like dreaming about it. Yeah. Anyway, so this is layer 2. And then, remember I told you, right? VXLAN goes across layer 3. Hang on. Hey, wake up. He's being naughty. All right, so you have layer 3. Okay. So this is the IP, right? So you'll see the source IP address and destination IP address. And notice the source is 10.0.0.195. Well, let's see. So that should be the Nginx. And you see that, 10.0.0.195. So that's the internal IP for Nginx. And obviously the other one is for Wireshark, right? So that part is okay. So you can see that it's a communication, layer 3 communication coming across, right, between those two servers. But what's interesting here is we're not interested in that, right? We're interested in what happened between the internet, me, and the Nginx, right? So that is actually encapsulated inside L3. Here, see where it says it came in on user datagram protocol. I said that this actually works on UDP. So it's UDP port 4789, right? 4789. Then inside that UDP, right? Look at that. You have virtual extensible local area network traffic. See, this is the VXLAN that we're talking about. It says, okay, so that's the VXLAN, right? That's coming. Right? And we'll see pretty soon. And what is this thing? Well, it's a layer 2 information, right? It encapsulates layer 2. Is it really? Yeah, look, because look, right after that, you have Ethernet 2. See that? Okay. So you have Ethernet 2 with destination MAC address and source MAC address. Isn't that interesting? So that's the different MAC addresses, because now we're talking about the actual me talking to the web server. But, to be a little bit more clear, inside the layer 2 that's encapsulated, there is layer 3 information, and there's also layer 4 information that's encapsulated into that. So the layer 3 information says the source is 141.239.143.196. Destination is 10.0.0.195. So we know that destination is the Nginx, but who in the world is 141.239.143.196? Who's that, right? Well, let's do this. So if we do a very popular, what's my IP? Okay. So my IP is 141.239.143.196. You see, that's my IP coming from my Mac from Hawaii. Okay. So that was encapsulated right there. So that is the information that it just captured. And then it says, okay, so that's the traffic between Terumi and Nginx. And then what was that? It was actually a HTTP information, right? So here's the HTTP. I picked something that probably wasn't that exciting, but it's just kind of, sending over the HTTP header information, which has, it says, look, it says Macintosh, right? So the user agent is Mac with the OS, and it probably has I think I contacted this using Chrome. So there should be some Chrome information in here as well, I think, right? So there you have it, okay? And this is how you do the capture. Obviously you're going to have to be able to extract this information, traffic, the split traffic. What's really nice about this is that, let's say I have like 2 Wiresharks. I'll say, I just want to look at the TCP information going to one, and I want UDP information go to the other. So you can just manipulate this anything, any way you want. Now, for the longest time, as far as I remember, this traffic mirroring was not available. If it wasn't available, you really didn't have much choices about, how do you capture traffic, right, in AWS. So there you go. Now, there's one more thing. I just want to take just another 5 minutes to give you just one more information. So right now, we're doing, let's say, let me see here. Right now, we're doing this, right, inside one VPC. Now, is this best practice? As it turns out, no, this is not the best practice. You probably don't want to put everything in one network. So the way that is normally done is you would have multiple accounts, right? So you have multiple accounts where, let's say you have, let's say initially you can have multiple VPCs if you want, right? So let's say you have a VPC 1 and VPC 2, right? So you have VPC 1 and VPC 2, where this, let's say, is a security monitoring VPC. Right? So you can control access better at the edge of the VPC, right? So that you have something like a, Wireshark here. Okay, and then you would have these source coming in from here, right? So these will be the sources, and you could definitely have, multiple VPCs. Okay, and the way you do this is you connect them together using something called Vpc Peering. So that you can connect these VPCs. In fact, there's no transitive connection, so this would be the VPC connection. You know what? That's probably not a good way to draw this, because this is not how it works, right? So the way it works is that you create a VPC peering here, right? And then you create another VPC peering like that. So that's basically how you create a VPC peering. Now, is this the best practice? It's getting there, right? But if you really want to do a great job at doing this kind of monitoring, you would put it under a separate account. Why? Because if you have, let's say this whole thing is in one AWS account, let's say, right? So this is in one account. Right? If you have, somebody malicious, here we go, but that's my rendition of a black hat, okay? And if they were to attack this thing, right, the whole thing is going to go down. It's possible, right? Okay, because if an account gets hacked, the account gets hacked, right? So the way to avoid this mishap not avoid, but reduce the risk of this happening, the best practice is actually to put it on multiple accounts. So you would have, let's say, account. So instead of having separate VPCs, you have separate accounts, right? So you have account 1, you have account 2, and you have, let's say, a security account. Okay, and then you would do, you have the VPCs inside it. So let's say you have a VPC here, and VPC here, and you have your Wireshark here. I'll put IDS in here. Then what you do is you would go ahead and do a VPC peering across accounts. Now, why is that better, right? Well, this is because in AWS lingo, they call it to reduce the blast radius, so that if someone were to, let's say, hack into one account, it's not going to do much damage to other accounts. Hopefully, you're using different, different authentication credentials. And, I'm sure you could definitely double up on the security account too. But, usually with security account, you have like maxed out on the security measures that you take into place, like very, very strong authentication and stuff. So that hopefully, people are not able to come into your security centralized account and try to trash it. Okay. So although I'm not going to be able to show you the actual lab on this, I actually did part of it. Okay, so I just want to show you how these peerings work. Right, so here we go. Not that I don't want to show it to you, right? It's just that for lack of time. So here, so this is where my Wireshark is at. Right, so this is my. Hang on, is it? It is. Yep, this is where my Wireshark is at. So let's see if we were to go back to. Right, you can see there's Nginx. But what I'm going to do right now is I'm going to make this smaller, and I'm going to show you a second account. Okay, so this is a second account. Okay, totally separate account, and you can tell because it says PFJ student 24, and this one says PFJ student 25. So they're separate accounts. Okay, but they are connected together. So let's take a look at the VPC. And if we do VPC here, I have just one VPC. There it is, class 2 VPC. And the CIDR addressing for this one is 192.168.0.0.16, right? So for this one, though, if I were to go to VPC, and if I were to go to VPC here, okay, this class VPC, the CIDR is 10.0.0.0/16. So you can see that there's a totally different account altogether. Okay. Now, and right now I have a web server running on this. So here we go. Let's see. Let me show you the EC2. So let's say I have an EC2 here, right? Just about 4 more minutes. And instance, and I have an Nginx running here. So if I were to grab hold of this public IP address, and if I were to, let's see, if I could just show you this website. There it is, right? So the web server is running. So that's on the second network, okay? And I haven't set up the filter, but I can, right? And what I did was I created what's called the VPC peering between 192.168.00/16 to 10.0.0.0/16, account 1, account 2, okay? And so let me show you that part, the VPC peering. Let me see, peering connection, okay? So I created the lab peering connection. So there it is, right? So they're connected. Requester VPC is this account that you see on left, and the acceptor VPC is the one that you see on right. Okay, and just to prove that it is connected together, is I could do a ping. So if I were to do, if I were to look at the instance, right? If I were to look at the instance, you see that the IP address is 192.168.1.103. Okay, sounds good. So if I were to go back into this guacamole, and let me see if I can actually, let's see. You know what? Let me just go ahead and do this over here, 8080, and just kill that session. Okay, so let's see if I can actually go into SSH. All right, so here I'm in the Wireshark server, right, as an SSH. And let's see if I can ping it, right? So if I say ping 192.168 1.1.103, right? Crossing my fingers. Okay, so yeah, see it pings. So now that you see that they are connected together, and all I would need to do is to create a filter, right, on this account here to send it across to my Wireshark that's on the separate account, and it should start picking up that account information as well. All right, well, that's kind of, I hope you were able to get something out of that. Any questions at all? So that actually concludes my presentation in my lab. If you have any questions, I'm open.
Thanks so much. I'm gonna stop the recording.